Hi grade 12s, welcome to my channel. Hopefully you're going to learn something. This was a request by one of you guys for me to look at question 6. Okay, so this was November 2019. Yeah, 29 2009. Okay, so let's have a look at this question. Okay, now we are given a sketch below that represents a graph of the parabola f of x equals half of x. Obviously our half is a value less than 1, so it says the graph is widely opened. Okay, it's a wide cup, and seeing that that half is also greater than 0, then our graph is concave up. And seeing that there's no shifting horizontally, vertically, or whatever, it's just a mother function of our parabola, so it cuts through the origin. Okay, great. Then we've got g of x, which is given by minus. That negative speaks to our numerator of that fraction being negative. So what does that tell us? It tells us that our a value is less than 0, and obviously our graph should be in the second quadrant as well as the fourth quadrant, and we can see that. And then obviously we look at the denominator. We'll appreciate that that constant term in the denominator, the opposite sign of it gives us our vertical asymptote. So that means this is at minus 1. Alright, and we look at this one as well. We'll realize that that value, we take it as it is, it gives us our horizontal asymptote. So that is essentially those graphs. And where do these asymptotes meet? They meet at this point. So that point is given by minus 1 and 1. And it's literally the center of our hyperbola. Okay, now P and Q are points of intersection of F and G. Alright, so we can see them. Even at the origin, they still intersect. Okay, so not a problem. So now we are told to show the coordinates of P and Q are as described there. Alright, so let's start. So question 6.1. What do we have? We've got F. Okay, maybe let's write better. At P and Q, we understand that F is equal to G. Okay, so this implies that half x squared equals minus 1 all divided by x plus 1 plus 1. Now we still have half x squared equals, here we'll look for the common denominator. Remember, this is over 1, or LCM, which is 1 times that. It's just going to be x plus 1. X plus 1 divided by x plus 1 is 1. 1 times the numerator, it's minus 1. Plus x plus 1 divided by 1, it's x plus 1. Times 1, it's going to be x plus 1. So this means if we just effectively sort this out, this is as good as x squared over 2 equals, we sort this out, we get x over x plus 1. And now what do? Cross multiply. So when we cross multiply, what do we get? This is going to be x squared into x plus 1 equals 2 into x. Okay, then we sort this out. This becomes x cubed plus x squared, and then this one becomes minus 2x equal to 0. We take out the highest common factor, get x squared plus x minus 2 equal to 0. We can factorize this. It's going to be x plus 2 minus 1. Therefore, x is equal to 0, or x is 1, or x is minus 2. Now, if we look at our sketch, we will see that point P is on the negative x-axis. So, if that's the case, it means there we must have minus 2, right? And if we look at Q, it's on the positive x-axis, so that should be 1, because 0 is at the origin. So we can make a conclusion, therefore, that x at P is minus 2, and x at Q is going to be 1. This implies that y at P, we can use the parabola to substitute. It's going to be, as we see it. Now, therefore, y at P is going to be, this is 4 divided by 2, it's 2. And y at Q, this is going to be just a half. Okay, so therefore point P is going to be minus 2 is to 2. And Q is 1 and a half. Okay. So very simple stuff there. Not a big deal. So 6 marks. So obviously, each one of those coordinates are important. That's what we have. So 4 marks already. And then equating the 2, that's the 5th mark. And of course, whatever gymnastic, this full factorization perhaps is the 6th mark. The final answers don't necessarily get a mark because we have already been shown what they look like. So even the marks may be somewhere else. Not a difficult question there. So let's look at question 6.2. Question says, an axis of symmetry of the graph of G is a straight line defined by y equals mx plus c, where m is greater than 0, so that's the positive gradient one. Now we need to write down the equation of this straight line in the form y equals h of x equals, okay? So great. So now what are we going to do? We know that there's 2 ways. We can say h of x is equal to x minus p plus q. So this means from the standard format, that which is on the denominator, we put it as it is there. And that which is the q, we put it as it is. So this implies that our h of x is basically x plus 1 plus 1. Therefore, h of x is x plus 2. And that's the answer, okay? But now the question, guys, said write down. So always attempt to just give the answer only in a situation like that. Because if it happens that your argument here is incorrect and you end up with the right answer, then you will be marked for the incorrect stuff. But if everything correlates together nicely, then the final answer, when underlined, is what gets marked, okay? Great, so that's how you do it. So, or, how else could you do it? We can say h of x is going to be x plus c. We know the gradient is 1. For the axis of symmetry, the gradient is always 1. And for the positive one, it's going to be a plus 1. But then we have to substitute the coordinates of the center, or the point of intersection of the asymptotes. So with this minus 1 and 1, this is going to say 1 is equal to minus 1 plus c. Therefore, c, you transpose this, it becomes positive. 1 plus 1 is a 2. So we can write our equation nicely now. say therefore h of x is basically x plus 2. So nothing really complicated, short and to the point. Okay, now we're told to determine the inverse in the form y equals, very easy also, 0.3 h. The inverse of h is such that x is equal to y plus 2. Remember, we switch x and y. Now this implies that y is going to be x minus 2. Therefore, the inverse in terms of x is going to be, or they didn't ask us, they said in the form y. So we can just forget about this one. You can say therefore y equals x. In fact, I should not have wasted time also. This is already done here. Alright, so the other issue, it says determine. Usually determination, we need to show the switching of x and y, and finally solving for y. Okay, great stuff. So let's do the next question. So we have 6.4. Now 6.4 says we need to show algebraically that g of x plus g of 1 over x equals g of minus x times g of minus 1, where x is not 0 as well as not 1. Why? Because when x is 0, what happens? This becomes undefined, okay? But when x is 1 in the original, what happens? What is cooking? Why is, sorry, this one becomes 0, so it doesn't work. Okay, great. So now let's have a look. What is cooking here? What is the story? We can start off by choosing the left hand side, because remember, this is more like proving identities in algebra essentially. So we've got g of x plus g of 1 over x. Okay, this is equal to g of x is minus 1 over x plus 1 plus 1 plus, now this is minus 1 over, where we see x we put 1 over x plus 1 plus 1. Alright, so this implies, this is equal to, now obviously guys, we need to deal with this alone and deal with that alone. So when we deal with that, this is over 1, the common denominator in there is just going to be x plus 1. And we'll say this divided by that is 1, 1 times the numerator is minus 1. This divided by that is this times the numerator is still this, so it's going to be plus x plus 1. This is the big plus, and then we look here again and say fine, this is over 1, so the common denominator is x plus 1. Mistake, big one, big mistake. So obviously before we can do that here, we have to deal with this issue right there. Okay, so this issue forces us now another way. So obviously what I do here to sort this out, just to avoid a long lengthy expression, I just take this and multiply it there and then add that. So what I have here is minus 1 over, so x times 1 is x plus 1 is basically x plus 1. Or we can say it's 1 plus x, it doesn't really matter. You can say this is 1 plus x all over, the common denominator is going to be x, alright? Then we have plus 1 over there. Okay, alright, okay, so this one sorts itself out, we end up with x over x plus 1. Plus, when we deal with this one flips to the numerator, it will multiply that x, and that becomes the denominator. So we will have here, maybe let's put it under brackets because of that negative. But I mean, it's not much of a big deal, but let's do it. So this is going to be minus x over, x plus 1, it's as good as x plus 1 plus 1 over 1. Okay, not a problem. This this is equal to x over x plus 1 plus, we sort this out, common denominator is x plus 1, so this gives us minus x plus 1. Okay, now we continue, so we've got x over x plus 1. Now what happens here, the x's cancel, so we end up with just plus 1 over x plus 1. Now the common denominator here is x plus 1. Then we have x plus 1. Now this is effectively equal to 1. Okay, maybe let's write it down here. Because x plus 1 divided by x plus 1 is 1. Okay. Nice and easy. And then let's look at the other one. So let's see, what about the right hand side? We have g of minus x, is it? Yes, times g of x minus 1. Now this is equal to, g of minus x is minus 1 over, where we see x we put minus x, then plus 1, plus 1. This one we multiply to minus 1 over, where we see x we put x minus 1, plus 1. Plus 1. All right. So here one needs to concentrate. Again, we've got a situation there. The common denominator in there is going to be minus x plus 1. So that leaves us minus 1 minus. Remember, now we're going to say this divided by 1. It's this multiplied by the numerator. What happens? We get minus x plus 1. Okay. All right. Now we sort this out nicely. So we have minus 1 over, this is going to be just over x plus 1 over 1. Okay. Then we continue nicely. The ones cancel out. We have minus x over minus x plus 1 into the common denominator here is x. Then we'll have minus 1 plus x over there. Okay, good. Now that we have it sorted, we can essentially multiply. Now as we multiply, that x and that x cancel out actually. And this one, okay, let's leave this one as it is. It's a bit strangish. So now we have a minus into 1 minus 1 plus x over minus x plus 1. When we distribute that negative, we get minus x plus 1 over minus x plus 1. This is equal to 1. Therefore, we can say the right hand side, is it the left hand side? We start with the left hand side is equal to the right hand side. The identity has been proven. Although this is just 3 marks, strange because there's so much work. Anyway, I don't know how to mark that literally. But for me, is to get those values that these are each equal to 1 and maybe the conclusion. It looks a bit strange, so one would have to look at the formal marking guidelines to ensure that the mark distribution is as planned by the examiner. But I think it's immaterial at this point. The key is to just get the right way of solving and get the right answer. The rest will fall into place. Alright guys, hope you enjoyed the video. I will see you some other time. Goodbye.